All right, so this lesson is about interpreting linear functions. There are some words that you need to know or you should already know, and those are these listed up here at the top. If you need to review any of these words, go ahead and look back in your notes to do that now because I'm not going to explain them again during this video. So function notation is something that you may or may not have seen before, and it is written like this, f parentheses x, and it is said f of x, and it literally means a function, so that's what the f stands for, in terms of x. So whatever they put in here is just what they're going to call the variable. For instance, you could have a function that says like h of t, which would be maybe like height in terms of time. So that's the variable that you're going to use. And let's say we were going to write an equation like f of x equals 2x plus 3. That is really just another way to write what you have originally written in previous lessons as y equals 2x plus 3. So just want you to be aware of that function notation because you're going to encounter that today. Okay, so before you go any further in this video, you need to have your calculator out because I'm going to be showing you a few things in some of the examples for today's video. So first of all, this is the TI-84. If you have an 83, the buttons are exactly the same. It will work the same. All of that will function the same. If you have another calculator, like I told you before, you may have to Google how to do some of these things, but your calculator does have these same functions. So first, notice just where the on button is. That's important. The two things that you're going to need to be able to use today, one of them is y equals, and it's what will give you a place to enter an equation. So notice when you enter an equation, you're obviously going to be needing to type like y equals and use an x value. And when you use an x value, you want to use this button right here for your variable. So you need to somehow note that for yourself for when we come into class tomorrow. The other thing that I want to show you is we're also going to be using a table function where it gives us a table of values. Now, when you look at your calculator, table is a blue word up here above the button graph. Anytime you need to use one of the blue functions, you need to hit the second button first. So you're going to hit second, and then this graph button or table, and that is what's going to spit out this table-looking thing on your calculator. So make sure you can follow those steps to do the examples we're about to do. Okay, we've got 3 examples in your lesson today. I'm trying to keep it as concise as possible. And so that you don't have to write down all of this information from the word problems, I'm going to underline what you need to write down for each one so that your notes are complete. So the first question, if you read it, says a cruise ship is currently 5 kilometers away from port and is pulling away from the port at a rate of 15 kilometers per hour. So one thing that they write for us that's really nice is they tell us the function y equals 15 x plus 5 tells us that the ship after X amount of hours will be Y kilometers away from the port. All right, and the question is asking how far will the port be, will the ship be away from port after 2.5 hours? So the first thing I want to do is talk about graphing. And this is something that you all could probably graph on your own right now. You know how to start at 5. You know how to use a slope of 15 over 1. Notice that this graph is not really counting by ones anymore. It's counting by ones on the x-axis and 5s on the y-axis. So you could do that, but what I want to do is show you how to make a table of solutions in your calculator to make this a little bit easier to do. So we're going to go ahead and go to that y equals function in our calculator, and we want to type in this function. Now notice, it already says y equals in your calculator, so you don't have to type the y equals part. You're just typing the 15x plus 5. And now we're going to use that to create a table of solutions. So we're going to use that table function, which I already told you was the second graph button. Okay, and when you do that, your table might show up looking a little bit differently. Like yours might start at 0, 5, instead of starting at -2, -25 like mine does. Here, I'll zoom in. So no matter where yours starts, you can scroll up using those arrows on your calculator to make yours start in the same place that mine is. Okay, so the first thing I'm going to do is go ahead and copy down that table for my notes. All right, and notice a few things. First of all, notice that I did not include these points at -2 and -25 because this problem is talking about hours and kilometers, and it doesn't make sense to start at -2 hours or to be -25 kilometers away from port. The other thing I want to tell you is that when we have solutions, so solutions, you need to go ahead and write this definition down, are points on the line or points that make the equation true. So solutions are always written as ordered pairs, so they are like x comma y. And if I was to name a few of these solutions, it would just be literally to take these sets and make them into an ordered pair, like 0, 5 or 120. All right, or we could say 235. These are all solutions. So we want to go ahead and plot these points to create our graph. So I'm going to pause the video and do that. And then there are a few other things we need to consider with this question. One of the first things we need to talk about is if this is an example of a discrete or a continuous case. And this question is talking about time and distance. So to me, I think this is a good example of continuous. So we're going to go ahead and I'm going to connect these points to make it look like a continuous graph. And then we need to answer the question, how far away from the port or is the port in 2.5 hours? Now, I'm going to show you tomorrow how to do that without using your calculator and with using your calculator. But for now, your calculator doesn't give us an exact answer. I know that it's going to be somewhere between 35 to 50 kilometers. So what I want you to do is put a star in your notes for us to come back to this question, but you can go ahead and note that 2.5 hours is somewhere in here, and we'll finish this one out tomorrow. All right, so here's our second example. Again, we're going to end up using the calculator to do this. So what I would like for you to do for taking notes, if you will go ahead and just write down what our function is, write down that x stands for the number of minutes and that we're talking about a hot air balloon and how high it is above the ground. All right, so like I said, we're going to use our calculators to answer these 3 questions. So you're going to want to go to the y equals section of your calculator. Notice that when you do that, your old equation should still be there. If you hit the clear button, it will just delete that old equation and you can type in your new equation. So I want you to type in your new equation and go ahead and try to open up the table so that you can look at the values that it's going to give us. Okay, so remember, my table is starting at -2, yours might start somewhere different. If we want to identify and interpret, so one thing that you need to make a note of, a star of in your notes or a point of, is that interpret is going to mean that you need to write a sentence to explain what that point has, like what significance that point has, rather. So remember that x-intercepts are written in the format a number, comma, like some number, comma, 0, and that y-intercepts are written in the format 0, comma, a number. So I notice on my screen right now, I already have this y-intercept right here, and it is 0, 750. So I want to write a little sentence to interpret what that means. And I know if I go ahead and label my table here, I know that x stands for the number of minutes, and that y is going to stand for the meters high, or how, like the height that you have of the hot air balloon. So 0, 750 is going to mean that after 0 minutes, the hot air balloon is 750 meters above the ground. Another way you could say that is to say at the start or at the beginning, the hot air balloon is 750 meters off the ground. All right, now we also need to identify the x-intercept. And if we go back and look at our table as it is, I don't see anything written in the format of like a number, comma, 0. So what I actually need to do is scroll using the up or down arrows to find that point. So I want you to go ahead and do that, pause the video, and scroll and see if you can find the x-intercept. All right, and I had to scroll for a minute, but I did eventually find it right here at 30, comma, 0. So I'm going to again write my sentence. After 30 minutes, the hot air balloon is 0 meters off the ground. Or after 30 minutes, the hot air balloon has reached the ground. However you want to form that sentence. All right, now there are 2 more parts to this question. I both think that they get pretty quick, though. The other thing says to name and interpret another solution. Remember, solutions are just ordered pairs. So you can pick any ordered pair in your table and write a sentence. For example, I could pick 4 and 650, and my sentence would say, after 4 minutes, the hot air balloon is 600 and, well, hopefully I write the right number, 650 meters above the ground. Or you could pick 26 and 100. After 26 minutes, the hot air balloon is 100 feet above the ground, right? There are a ton of different options that you could choose to pick that. All right, and then the last thing we want to do is state the domain and range. And here it's important to know that domain and range, right, domain is talking about our x values, which is talking about time. Range is talking about our y values, which is talking about height. We know that time and height can be continuous, so I am going to note that this is a continuous graph, if I were to actually look at it as a graph. And then we're going to list our domain and range. So it's going to look like an inequality. So I'm going to say, I want to think about what's the low number and what's the high number for the x values and for the y values. So in my x values, right, I'm starting at 0, that's the low. And the highest x value that makes sense for this problem is 30. Remember, these negatives don't make sense because we can't have negative time and we can't have a negative height above the ground, right? This hot air balloon is not going to burrow itself into the ground. So my x is going to be from 0 to 30 minutes is kind of how we set that up. And then for my y values, I'm looking again at the lowest and the highest. Now notice the y goes backwards, but that's okay. The lowest y value is 0 when the hot air balloon hits the ground, and the highest one is 750. So we're going to write that as 0, 750. All right, let's do one more quick example. All right, the last thing I want to do is show you how to interpret the rate of change. And rate of change is kind of similar to slope. To be honest, you're not going to really see a difference until we talk about some other applications of it. So in this example, you're already going to be given a graph, so we're just going to find the rate of change or the slope. So notice that we're going to do rise over run, and I'm going to count from the first point to the second point. So kind of pay attention to what it's counting by, but notice this is going from 180 to 150. So if I go down, that's like I'm going down 30 or negative 30. Now, if we're supposed to be doing this in context, like to write a sentence, we need to talk about what is changing. So if I go down 30, that's decreasing 30 beats per minute. Beats per minute. That's the heart rate that's decreasing. And then, so we're going to do, like I said, we're going to do rise first, just like we normally would. And then we're going to interpret run. And here if I run, I'm running from 20 to 50. Which is a run of 30. And if I look on the x-axis, I'm counting years. So if we're going to state and interpret this in context, the first thing we're going to want to do is to simplify. And remember, when we talk about rates, like one of our rate words is always something per something. So we want to reduce this so that it's per one, whatever we're talking about. So in this case, we want to reduce it so that we have per 1 year. So I'm just going to divide, and that's going to give me, for this problem, that's going to give me -1 beat per minute over 1 year. Or if I state that in words, because we're thinking about like if we were to go back and write a word problem, we would write that the heart rate decreases 1 beat per minute each year as a person ages. And this is kind of a more complicated example. So if you're following this one, that's a good thing for tomorrow. If not, you should at least understand where I'm getting this rise and run, that we need to simplify, and where I'm getting these labels from in order to interpret rate of change. So that's all for this video.